Hello, this is lesson 14, Benzoid Aromatics. So first, whenever we see xylene, we know there's going to be two methyls attached to the benzene ring, and the indication of where it's at is based off of this ortho. So if you saw my last video with homework 13, you'll know that ortho means that the two functional groups are at the 1 and the 2 positions. So I just added my double bonds. I add my methyl at the 1 and my other methyl at the 2. Add my hydrogens. And let's see if it has us do the cyclic pi electrons. So we just counted twice, 1, 2, 3, 4, 5, and 6. Okay, turene. So this one I actually had like a list of, what was it? I looked up like list of common names for benzene aromatics, and it actually came up turene. There's different ones that came up. Let's see. So it said C6H5 and then a CH3. So it looks like it's going to be a benzene ring with a single methyl attached. So let's go ahead and draw that. I know you can't see on my side. I'm just pulling up like on Google the different things. Okay, and then I'll add a methyl because that's what it said. So we'll see if that is right. Okay, I'm going to leave it like that, and then we're going to have six cyclic pi electrons in the end. Awesome. Okay, tetracene. This seems like I'm going to have 4 methyls. I'm going to go ahead and go on Google. What my prediction is that I don't really know if I'm right, but I feel like we're either gonna have 4 rings or 4 methyls attached. So let me go over here and look it up. Tetracene. So my favorite site didn't pop up first. Okay, 4 rings, which makes sense because you got that tetra. So I guess it should have made more sense that it didn't say tetramethyl or anything like that. So we'll just do our 4 rings. Let me undo that. Four rings, and then we're just going to add double bonds. We don't want any double bonds touching each other. So I'll put one here, one here, one here, one here, another one over here, skipping single bonds in between. Let's see if I can put one here. No, I can't because this carbon would have too many. Right here, down here. Is really a double bond. So this one you just gotta keep an eye on where you put your double bonds and make sure you're not adding anything here. This one can't get them. This one can't get them. This one can, and this one will. Add my hydrogens. Fit it. Let's see, I don't want to see any carbon that has 2 hydrogens sticking out because that means that I missed a double bond. But it looks good. I'm going to go ahead and count my lines. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2 is 18. So I'm just counting those blue lines. You can count them individually, one like on the left, that would have 6, but I'm just going to count all of the blue lines once and then multiply by 2, which gave me 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see if this is right. I said 18, so let's try it out. Okay, I've got 3, so I've got a trimethyl. There's an actual name for this, but so normally I would put 1,3,5 trimethylbenzene, but I can also put mesitylene. Hopefully I spelled that right. We'll go ahead and see. Awesome. Oops. Sorry, I'm writing down the different answers I'm getting. Okay. We've got that ortho again. So we have xylene because we've got 2 methyls, so we can just add that already. Xylene, and then they're at the 1 and 2 position, so I can put O, oops, not 0, O dash xylene. Or you can do ortho xylene. You can also do parentheses 1, 2 dash xylene. I don't know if you'll have to, I think if you do 1, 2, you have to add the methyls. But I'm not entirely sure. I think you would do 1, 2 dash methylbenzene or something, dimethylbenzene. But I haven't tried that. Alright. Okay, paraxylene, so I know there's going to be 2 methyls attached to this benzene, and they're going to be para, so they're going to be adjacent to each other. One's going to be at the 1 position, and the other one's going to be at the 4 position. I'm going to add my double bonds before I add my hydrogens. Make sure you always have 6 carbons in the ring. It's easy to add one and take one off, but usually it'll look weird once you add your double bonds and something's not right. So paraxylene, and then we've got 6 cyclic pi electrons because I counted those blue lines, the double bonds. Metaxylene, so this means that we're going to have those methyls again, one at the 1 position and one at the 3 position to indicate that it is meta. We just did para, which was adjacent to this one, so it was at the 1 position, and then at the 4 position, we also did ortho, where it was the functional group was at the 1 position, and then the other one was the 2 position, so we finally get meta to add to our trio, and it shows at the 1 position and the 3 position. So this is what we get at the end. We have the same amount of cyclic pi electrons, just 6. So we'll go ahead and put that. Okay, we just had this one too. We have 1 ring, 2 rings, 3 rings, 4 rings. So we have a tetracene. And I'm gonna get my charger. I'll just submit it. I don't think it's gonna ask for the cyclic pi electrons. No. Okay, let me fit it to the screen so I can see everything. Oh, and this is one he gave. And he gave it by the systematic name, which was Cumin. I'm thinking if we name it systematically, it would be like methyl ethyl benzene, but again, I haven't tried that because I'm trying to get 800. I hope I picked the right one. Okay, was this the last one? Okay, no, we have one more. Phenanthrene, so this one as well, you can go ahead and look up. It's hard to tell with the systematic names. This one, I drew it all weird in my notes, but I'm gonna try to draw it right. So we're gonna have 2 rings, is what it looks like. we're gonna have this. What do I have in the bottom? 1, 2, 3, 4, 5, and 6. I know it looks weird. I'm gonna add my double bonds. So again, I'm not gonna have them next to each other because that would be too much for the carbon. So I only want 4 bonds on each carbon. I don't want to overcrowd it. It's the word I was looking for. Okay, now I'm going to add my hydrogens, hit arrange, and that should look better. Yeah. It looks a lot better. And next I'm going to look and see if I have 2 hydrogens anywhere, because that's an indication that there's not a double bond where it's supposed to. I know this might look a little weird this side, but if you think about it, if you were to have a double bond here, you can't add any more double bonds. So it looks right to me. I hope it's right. I'm gonna, since this is a drawing question, I'm gonna count the blue lines and multiply by 2. So I got 1, 2, 3, 4, 5, 6, 7. I'm gonna go ahead and put 7 times 2, 14. Sorry, I'm double checking because this molecule looks so weird. Yeah, I don't know how else I would do it, so let's just check it out. I'm gonna put 14 and hope for the best. Awesome. I think that was it. So good luck on this one. And again, keep a notebook. It'll really help out. That's what I've been doing. And yeah, until next time, good luck.